Welcome back. Question 1 was about trigo identities and question 2 is about logic and intervals. We have two sets over here, set A and set B, defined by modulus inequalities. Our goal is to check which set operation over here is correct. In JEE Main, the difference between a square bracket and a parenthesis is the difference between +4 and -1. Today we are tackling a sets and inequalities problem from the 2026 series, that is a masterclass in boundary traps. Let's think sharp and decode these intervals together. But before we dive into the calculations, let's look at the sharp tools we need in our arsenal. Modulus inequalities can be tricky, but these properties are your roadmap to getting them right every single time. So first, take a screenshot of these. These 9 properties are the roadmap we will use to dismantle set A and set B. Without these, you are just guessing, but with them, you are calculating with 100% certainty.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
Notice the first property under basic identities. Root over a square is equal to modulus a. This is where many students lose half their solutions. Never forget that the principal square root must be non-negative. Now let's start decoding set A. To solve set A, we will first use the property number 7. So in our case, modulus x square minus 10 is less than equal to 6, which means x square minus 10 must lie between -6 and +6. Now if we add 10 to all sides, we get 4 less equal to x square less equal to 16. Now to find x from here, we need to take the square root of all sides. But remember property 1 from our list? Square root of x square is equal to modulus x. So the inequality becomes square root of 4, which is 2, less equal to modulus x less equal to square root of 16, which is 4. Now this expression is telling us two things simultaneously. Case 1, if x is positive, it's straightforward. Then modulus x is equal to x, which means 2 less equal to x less equal to 4. That gives me x belongs to interval 2, 4. But if x is negative, remember that modulus x flips the sign, which means modulus x will be equal to -x, which means the inequation becomes 2 less equal to -x less equal to 4. So, for modulus x to be between 2 and 4, x must be between -4 and -2, multiplying every side by -2, so the inequality sign also changes, which means x must belong to -4, -2. Now combining these two, we get the complete set for A. Always double check your boundaries. Since we have less than or equal to, we use close brackets to show that -4, -2, 2 and 4 are all included in the set. Next up is set B. Now looking back at our roadmap, we use 8th property. This property is for values greater than, which means the solutions are pushed away from the center into two separate wings. So let's apply it to our expression. So in place of x, I have x minus 2. So either x minus 2 is less than -1 or x minus 2 is greater than 1. Simplifying both sides, we get, just adding 2 on both sides, we are getting x less than 1 or x greater than 3. So if you want to visualize this on the number line, that creates two infinite rays starting from 1 going left and 3 going right. So in interval notation, this becomes b is equal to -∞, 1 in parenthesis union 3, infinity. Since the original inequality used is a strictly greater than symbol, so the numbers 1 and 3 are not included, and that's why we use open parentheses instead of square brackets. And here you can see we have used empty bullet just to show that 3 and 1 are not included on the solution. But in the number line of A, we have used a filled bullet, a solid bullet, to show that these numbers are included. Now that we have both the sets, we can check the options. The first option is A union B. So let's try to find A union B. Union means we take everything that belongs to A and everything that belongs to B or both. Let's trace it from left to right on the number line. So from minus infinity to 1, this entire region is covered by set B. So which means it is included in A union B. Now from 1 to 2, there is nothing here because set B ends at 1, which is not included, and set A starts at 2. So 1 to 2, this interval is a gap. It belongs to neither set. Now from 2 to 4, this region is covered by set A. So we include that. And from 4 onwards, this region is covered by set B because it starts at 3 and goes to positive infinity, right? So when we combine them, we have the region from negative infinity up to 1. And then we jump the gap to start again from 2 all the way to positive infinity. So let's look at option 1. It says this. So obviously option 1 fails over here because it flips the inclusion logic for the boundary points 1 and 2. In JEE, a parenthesis where should be a bracket is the difference between +4 and -1 marks. This is why you must check your sharp tools, that is the properties, every time. Now since option 1 is out, let's look at A intersection B. To tackle A intersection B, we are looking for the regions where both sets overlap on the number line. Now set A has a block from -4 to -2. Now since set B covers everything from minus infinity to 1, it completely swallows this negative block, right? So this part, -4 to -2, must be included in A intersection B. Now the middle gap between -2 and 2, set A does not exist. Between 1 and 3, set B doesn't exist, so no overlap here. Now let's see the positive side. Set A has block from 2 to 4. However, set B starts only after 3. So where do they meet? They start overlapping at 3 and stop at 4. So 3, 4, where 3 is not included, will be in the intersection. So combining these two pieces, we get this. So let's look at option 4. Notice that square bracket at 3. This implies that 3 is included in the intersection. Since 3 is not in set B, it cannot be in the intersection of A and B. So it must be an open parenthesis, right? So this is exactly why JEE is as much about eye for detail as it is about math skills. Most students will solve the inequalities perfectly but pick option 4 because they didn't respect the open interval at 3. So in our series, we don't just solve, we verify every bracket. And this rules out option 4. Now for subtractors challenge. Let's have a look at A minus B. And let's see what remains of set A after we carve set B out of it. Now subtraction in set means keeping everything in A but remove anything that also belongs to B. So let's look at A's first block. -4 to -2. Does any part of B overlap here? Yes, B covers everything up to 1. So the entire -4 to -2 interval is removed. Now let's look at second block of A, which is 2 to 4. Now from 2 to 3, this part of A does not belong to B, since B's positive wing only starts after 3. So this part stays. But from 3 to 4, this part belongs to B. So we must cut it out. Now the boundary check, very important. Since 3 is not in B, because you see we have an open bracket over here and an empty bullet over here. So when we subtract B from A, 3 actually stays in the result. So A minus B is 2, 3, where both 2 and 3 are included. So we are left with the piece from 2 to 3, including both ends. And let's see the option. Look at option 3. It missed the square bracket at 3, right? So this is another classic bracket trap ruled out. Finally, let's look at option 2. We start with B's left wing. Minus infinity to 1. And we subtract A's negative block, which is minus 4 to minus 2. And this clips the middle out of the B's left wing. So we are left with minus infinity to minus 4 and minus 2, 1, where both the numbers are not included. Since minus 4 and minus 2 were in A, they are removed from B, so leaving open parenthesis at minus 4 and minus 2. Now we will subtract A's positive block, which is 2, 4. We only need to care about the part of A that overlaps with B, which is 3 to 4. So if I subtract that part from the ray, that leaves us everything from 4 onwards. Since 4 was in A, it also gets removed, leaving an open parenthesis at 4. So the final result, when we put the remaining clipped pieces together, we get this. And there it is. Option 2 matches our calculation perfectly. In this video, we saw how option 1 failed on union boundaries, option 3 failed by excluding the number 3, option 4 failed by including the number 3 in an intersection. This is the level of precision you need for JEE. It's not just about solving inequalities, it's about mastering the intervals. If you found this deep dive into set subtraction helpful, make sure to like and subscribe to Think Sharp Alley. See you in question 3.